in both pieces. So we're going to plug 40 in twice, but that second time we plug it in, it's going to be squared. Now, if you have to leave it in terms of pi, I would just do this kind of in two separate steps. For the first piece, I'm just going to multiply the numbers and leave the pi out of it. So I'm just doing 2 times 40 times 37. That's gonna, and these are huge numbers, so don't think we're doing anything wrong. So it's 2,960 pi. The other one, I'm going to do 2. The radius squared is going to be 40 squared, so don't forget to square the 40. This is 3,200 pi, and then those guys are like terms. So we're just going to take the 2,960 and add the 3,200 to it. That'll leave it in terms of pi. So I'm just kind of bringing the, oh, sorry, I just wrote those backwards. This is just kind of writing the pi next to it, leaves it as an exact answer. And then you won't have to worry about any labels because it'll be in the multiple choice, but it would be 6160 pi millimeters squared. Okay, now hexagon area. We've done this a bunch. We did it in the area unit, and then we did it again in the volume unit because we had some different shapes like a pyramid or a prism that had a hexagon as the base. And forgive me, I probably should have put that 8 in a different spot. But remember, when you find the area of a regular hexagon, it's 1/2 the apothem times the perimeter. Now, the thing is with a hexagon, the central angles here, if I draw all 6 of the little triangles that make this guy up, central angle is 60. If you guys remember, and sorry, I put the 8 right here. I usually use that kind of to reference. The apothem is technically the distance from the center to any side. So I could draw it kind of anywhere in there. What it does, it splits that 60-degree angle into 2 equal angles, which are both 30. It also splits that side that is 8 into 4 and 4. Actually, let me come up here. We could find the perimeter of this without doing anything very much. If I know one of the sides is 8, how would you find the perimeter if it's a hexagon? 8 times 6. Yeah, multiply by the number of sides. So hexagon. It'll be a hexagon on the test, so that's why we're practicing this. All right, 48. And the apothem is the part that I think is tricky. So the apothem, here, I'm going to draw one of these little triangles. It's going to be this little dotted line, right? This is 4. This is the apothem. Okay, this is a 30, 60, 90 triangle. And so I'm just going to write the little formula for that. You have the short leg, I'll just call that x. The long leg is the short leg times the square root of 3. So if you know the short leg, all you got to do to get your apothem is just write a radical 3 next to it. So this would just be 4 radical 3. Those are the only 2 pieces of information. The question says round to the nearest tenth, so I'm just using this formula. Sorry, I didn't leave a lot of space on some of these questions. So I'm going to do 1/2. Apothem is 4 radical 3. Perimeter is 48. The only thing you have to be careful with, this does not say leave it in radical form. It says round to the nearest tenth. So when you type in, you're going to multiply that by the 4 square root of 3. If you're using a graphing calculator, just use a little arrow to get out from under the square root. If you guys have a parenthesis that pops up, just close the parenthesis because you only want to take the square root of 3 and then multiply by 48. So to the nearest tenth, I would go 166.3 on that one. And again, this is a, let's see, this is a surface area. And so this would be, it says 8 centimeters, so it would be centimeters squared. Yes, ma'am. Anytime it's a hexagon, yes. That's why we keep doing that, because you can use, it's got kind of like 2 skills in one, basically. All right. Now, if you guys look up here to the top of this, we did vectors. There's no question that asks you to find the components of a vector, so we're not going to spend our time doing that. So we're going to go ahead and skip 19. If it has an extra, it's not on the final. This one is, so this question on the final will have an actual picture instead of a description like this question does. I'm just going to kind of eyeball like a little bit of a picture of this situation to show you. So on the actual test, you'd have a picture of a circle. And then I'll see if I can kind of squeeze this on here. So it says find the area of a sector. Sector is just a portion of a circle, like a piece of pie or a piece of pizza, if you wanted to think about a physical representation. Find the area of that shaded part that we've got right there. The central angle is going to be used in the formula, so that's why they're telling us the 110. And they give you the diameter, but in this formula, you're actually going to need the radius. All right, so here it is. Here, let me start it out. This will be in the question, like typed into it. So your sector area, it's the measure of the arc, which is just going to be that central angle that they give you, and you multiply it by the area formula for a circle. So if I do pi r squared, it gives me the whole area. When I put that fraction in front of it, it just gives me the piece that we want. It doesn't give me the whole circle. So that's why we have that little fraction in front. Now, the tricky part to this question, they don't give you the radius, they give you the diameter. The 110 is the central angle and the measure of the arc are the same, so we could just put that in. Okay, now this is a little bit weird because the diameter is 5.7. If the diameter is 5.7, what would you do to 5.7 to find the radius? Divide by 2. Now, I know a lot of times we do questions in here, we're constantly rounding to the nearest tenth. I can't remember on the final what it is, but write out this whole decimal, right? Because it's 2.85. I cut that in half. That's totally correct. Then you're just going to plug that in for the radius. So you can type the whole thing. It says round to the nearest tenth, so I'm going to include pi when I do this. So 110 divided by 360 times your pi button, and then times that 2.85 squared. Excuse me. And then at the end, it does tell you to round to the nearest tenth. So, I don't know, like 7.8 for that one. And this would be centimeters squared because we are talking about an area. Number 21. This is way back towards the beginning of the year. Find the area of a kite. So I don't know if you remember this, so let me give you the formula. It's 1/2 d sub 1 times d sub 2. Does anybody remember what the d stands for in the kite? Not diameter, close. You could break that apart into a bunch of triangles and find that area, but this is a little bit easier way to do it. Anybody remember what would I use to plug in for those? Does anybody know? Would you not remember what the D stands for? Okay, this would be one of them. Segment that connects two non-consecutive vertices. You remember? Yes, diagonal. Okay, so it's just a diagonal. So diagonal just connects two vertices that aren't next to each other. Now this one's easy because you could just you can just count, or not count, but you could just add up the two pieces. So like from A to C, that's a diagonal, 6 and 15. So it doesn't matter which one is which, but one of the diagonals is 21. Now, the other diagonal, you guys can see it here, but in that particular part, I need the length of this diagonal. I only have this side labeled as 8. Does anybody know what, like, B to where that right angle is? What length would that be? Any idea? From B to, like, this much of it's 8. What do you think this piece is? It's also 8. Whenever you have a diagonal, or sorry, whenever you have a kite. Let me try and grab a different color I haven't used yet. All right, so there are two triangles that make up a kite. This is ABC, this triangle, and then I'm going to color this whole thing down here. And this triangle are congruent to each other. And so those pieces, that particular diagonal bisects the other diagonal. It's not the case going the other way, but one of the diagonals in a kite bisects the other. So this guy obviously not the same. This is 6 and 15. Those are not the same on either side, but one of the diagonals in a kite, depending on how the picture is turned, the diagonal bisects. The diagonal that runs between, like these two sides are both 10, these two sides are both 17. The diagonal that runs between those two bisects the other diagonal. So then my actual entire diagonal there 8 and 8 is 16. You just got to remember to get that whole line. Now, all you got to do, you grab your formula, do 1/2 times 21 times 16. Hopefully I'm on the screen. Area here is 168. This is an area, so it would be centimeters squared. All right, now I know we talked about this a teeny tiny bit on our last meeting together, but what I got going on here is some right triangle trig. So this is your SOHCAHTOA. So sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and then tangent opposite over adjacent. We're going to have to figure out from the picture which one we got going on there to set this up. So these are a little bit trickier, angle of elevation or depression, but it's just going to be a right triangle trig problem. It says the angle of depression, and it's kind of hard to see on the diagram here, but there's a little bird up here. So if the bird were to look straight ahead and then curve their eyes down to look at the dog, the angle of depression is 35 degrees. The problem with that is it's not inside the right triangle that we have drawn there. What angle could I figure out? If this is 35 from the bird looking at the dog, what other angle do you know that maybe would be inside the right triangle? Where would it be? Yeah, it would be 35. Where would it be?
Kind of next to it.
Here or here?
Up top.
Up at the bottom. And that always messes people up, the angle of depression. Okay, now, this is like a really long time ago. This guy, the 35, and then this guy down here, these are alternate interior angles. So the bird looking straight ahead would be the horizontal line. The ground would be a horizontal line. The angle between the bird and the dog is the same. Look in both directions. Angle of elevation and angle of depression between the same two objects is the same. So this would be your 35. So that's the key, is getting that into the triangle. Alternate interior angles there. Okay, once you have that, let me kind of ignore this part. We're going to find x in that picture. So I got to identify how the 100 is related to the 35. So opposite, adjacent, or hypotenuse? Opposite, because it's across from that 35 degree angle. What would you call x in this right triangle? It's tricky. So the adjacent and the hypotenuse look like they're the same because they're both attached to the angle. The way to tell the difference, the hypotenuse has to be across from the right angle, so x has to be the hypotenuse. It is attached to the angle, but it is the longest side there. And if you're doing angle of elevation or depression between the two objects, that side in the triangle will be the hypotenuse. Okay, so opposite hypotenuse is going to be sine. So I'm going to set up my equation. So I'm going to do sine of 35 equals the opposite, which is 100, over the hypotenuse, which is x. Does anybody remember how to solve the equation if the variable's in the denominator? We did one last time with the variable being in the numerator, and we would just like multiply both sides by the denominator. Anybody know what you do here if the variable's in the bottom? You can multiply both sides by x, for sure. So we'd have x times sine 35 equals 100. And then what would you do? Exactly. Sine 35 is just some weird decimal that you're going to get on your calculator. I don't know if you guys, I'm going to write this again over here just real quick. I don't know if you guys remember doing this. If the variable is in the denominator, algebraically, what happens is this sine 35 and the variable, they just end up trading places. You guys saw me go through that and actually do the steps there. To get x out of the denominator, you can multiply. You end up dividing by the sine 35. So if you want to use that as a little shortcut, if your variable's in the denominator, you're going to end up dividing. And then we're just going to grab the calculator because most of the time these are weird numbers. 100 divided by sine 35. And so the distance there, 174.3 to the nearest tenth, and this would just be in feet because we're just talking about a distance here. All right. Now, number 23, this is a really good question. So we're going to find the measure of this angle, YAC. That's what it tells you in the directions. That guy is what we call an inscribed angle. And an inscribed angle just means that the vertex is on the circle. If the vertex is on the circle, like this one is, there's a relationship between that angle and the arc I just highlighted. They call it the intercepted arc, like where it runs into the circle. Now, the only information they give you in the problem right here, this little bitty arc is 31. So it's labeled in the picture for you. From B to Y, it says it's 31. We're going to find the measure of this angle. Does anybody, the key to doing this question would be, could you tell me the arc that I highlighted in orange there? Anybody, like, how would I figure out how far this is? Exactly. Do you guys, this is a half circle right here, right? It's the diameter, that's the center of the circle. You're just going to do 180 minus 31, and it is 149. Now, that is the measure of that arc. Does anybody remember like, what do you do? What's the relationship between the measure of the angle and the arc that it intercepts? Like, is that angle 149 degrees? No way. I mean, you can see from the picture. What do I do with the 149 to get the angle? We could do that. There might be a little tiny bit faster way. What is the relationship between the angle and the intercepted arc? The 90-degree angle would be here. So that might be another way to do it.
Could you do the 149 minus 90 to get the measure?
Not quite, because that angle is not 149. You just divide it by 2. If you have an angle, the intercepted arc, if the angle's vertex is on the circle, all you're going to do to get the angle, measure of angle YAC there, you're just going to take the 149 and cut it in half. If you know the angle, you can multiply it by 2 to get the arc. If you know the arc, you can just cut it in half to get the angle. So just divide by 2, and so this is 74.5. That's reviewing a couple things in that question, because it's having you get the measure of the arc, the half circle, using the diameter there in 31, and then take the arc, cut it in half to get the angle measure. 24 is just 45, 45, 90, and looking back on this, I wish I had used different variables. So let me use, I don't know. I don't want to use S because that looks like a 5. Let me use A. All right, 45, 45, 90. 2 of the angles are the same. 2 of the sides are the same. Both legs are the same. The hypotenuse is the leg times the square root of 2. I'm just using A. So you'll have that picture, that formula. I think I have an X in the formula. If you have a 45, 45, 90, I know that my hypotenuse is 12 radical 2. That's what labels in the picture show. What would you tell me X has to be? So if I'm looking at this, it's just 12. It's just 12. Don't think about it too hard. Whatever the leg is, you multiply the leg by the square root of 2 to get the hypotenuse. So if this is 12 radical 2, this is just 12. Don't think about it too hard. I think some of these questions will be easier because the actual test is multiple choice, so it might be easier to look at. But we'll have those triangles available to you guys because we had those on the tests and quizzes too. All right, 25, I got another trig question. All right, so I've got a 55-degree angle. I'm just going to write my SOHCAHTOA up here. How is the 8.9 related to that 55-degree angle? Opposite, adjacent, or hypotenuse? Okay, what about the X? Perfect. Okay, you're going to use sine, cosine, or tangent? Okay, we're going to do tangent. Who could raise your hand and tell me how you would set up the equation? Gwen, go ahead. Perfect. 8.9 opposite over adjacent. All right, now, this is super similar to that question we just did. What were we using? Sine. This one's just tangent. So if the variable's in the denominator, these just trade places to get your answer. So all you're going to do, we're going to do 8.9, and we're going to divide that by tan 55. And it should just be, if you're not getting these numbers on your calculator, let me know, because you might just be in a different setting. But this should be about 6.2 to the nearest tenth, and this would be in centimeters. So the others, like, I don't want to, okay, if I use that same triangle, this would be a 35-degree angle. If I looked at the 35-degree angle, this would now be opposite and this would be adjacent. So another way I could set up that problem, which I'm not asking you to do, I could do tan 35 equals in that point x over 8.9. So in that case, what you would do is you'd multiply both sides by the 8.9 just to get it away. And I'll just show it's the same thing. So if I did tan 35 multiply by 8.9, I get the exact same thing. So, and you could do that if you wanted to. You can find the other angle. I usually just don't go to the extra trouble. But if the variable's in the top, you end up just multiplying both sides by whatever's in the denominator and you're done. That's a really, really good question. All right, let's look at 26. Surface area of a sphere. All right, right, my formula here, surface area, it's 4 pi r squared. That will be typed into the question for you. Now, all you need is the radius, but these jerks tell you the diameter. So, if my diameter is 10, what's my radius going to be? All right, 5. Now, leave in terms of pi. So, we're going to do our surface area, 4 pi times 5 squared. Now, if I'm doing this and I want to leave it in terms of pi, just don't type the pi. Just do 4 times 5 squared, and that's going to give me 100, and you just write the pi next to it. That's all you're doing. Just don't include the pi if it asks you to leave it in terms of pi when you do the calculation. Just multiply the numbers together there. And then, I'm sorry, centimeters. So this is centimeters squared. All right, now this one was throwing everybody off this morning, so we'll see if you guys can do this problem. So measure of angle B, sorry, the diagram's pretty tiny, is 45 degrees. And the measure of angle D, so B and D, are both 45 degrees. This is supposed to be, well, obviously it's a quadrilateral, but it says, what does C have to be for this to be a parallelogram? How would you do this? 180. Exactly. Just do 180 minus 45 is 135. Any two angles as you go around here, if it's a parallelogram, like B and C have to add up to 180, C and D have to add up to 180, D and A have to add up to 180. Actually, angle C and angle A are exactly the same. And any two sides, if it's a parallelogram or parallel to each other, let me kind of, I'll just look at B and C for a second. Like if these two lines are parallel, this is 45. If you guys remember doing that, between two parallel lines, just as an example, those are called same side interior angles. They have to add up to 180. So if it's a parallelogram, those lines would have to be parallel. So that has to be a situation where there's two angles add up to 180. All right, now 28. Please do not think too hard about this. This is literally just a right triangle missing a side. This is just trying to get you to do Pythagorean theorem. So like a squared plus b squared equals c squared. I have a missing side that's one of the legs that makes up the right angle. So I'm just going to call that a. Just as long as you don't make it the hypotenuse, you're fine. So the other leg is 12. And the hypotenuse, which I know it's the hypotenuse, is the 13 because it's across from the right angle. It's across from the right angle. That's the longest side. So all we're going to do, I'm just going to subtract 12 squared here real quick. And then we're going to take the square root of that number because that's equal to the side we're looking for squared. So just 13 squared minus 12 squared, we're going to get 25. And then what's the square root of 25? 5. Perfect. So the missing side there is 5. Just a Pythagorean theorem is all it's asking you to do. All right, let's see. Now, 29, and I feel like this has confused people as we've gone along here. So there's two different heights when you have a pyramid and when you have a cone. This is a cone. There is the slant height, which that is actually what they're giving us in the problem with the 17. The slant height is along the outside edge, like you could touch it with your finger. The actual height would go down the middle and touch the base in the center. This guy's like a little dotted line. You do not need that for surface area. You need the slant height for surface area, so you don't have to do Pythagorean theorem or anything here. Surface area of a cone is pi times the radius times the slant height. That gives you the part that wraps around the cone. And then the area of the base, which is just a circle, so that's pi r squared. Now, this is kind of tricky because it's going to ask you to leave it in terms of pi, and we kind of have two terms in this. So the radius is just the 5 in the diagram. The slant height is just the 17. I didn't have to calculate anything. They gave it to me. The radius is the same for both parts of this, so I'm going to end up plugging in 5 in two different spots. Here's what I would do to keep this in terms of pi. I'm going to kind of do this in two steps. Just do 5 times 17 for this first term. This is 85 pi. And then I'm just going to do 5 squared, which you guys probably already know is 25. So this is 25. And then to keep it in terms of pi, you literally just do like 85 plus 25. Those are like terms, then you have the pi next to it. So 110 pi, this would be centimeters squared since we're talking about a surface area. All right. Now, number 30. This is one of those circle formulas that we're finding a length here. We've got a secant and a tangent in this picture. So a secant runs into a circle in two different spots, but it goes outside the circle. So this line, the 12 and the 6, all that, that's a secant. Tangent, which it just draws a little bit of it here, would kind of intersect the circle right there, just brushes by the circle and touches it in one point. Okay, now I'm going to draw you guys just a tiny picture of the formula here just to make it look like the diagram that we have. And I honestly can't remember the letters they use, so I'm just going to use like an A, a B, and a C. So the relationship here is the distance between that point where those two intersect, those two lines intersect outside the circle, is the same as the distance to the circle along the line. Now this one's a little weird. So the outside piece to where it connects to the circle is just a distance of A. And then the whole thing, again, where I connect to the circle, would be A again. So I'd multiply those together. That's just going to give you A squared. The other part of it, the outside piece to where it connects to the circle is B. The other place, the other distance from this point to where it connects to the circle all the way here is just this entire thing. So what we would have to do is we'd have to add where I have the B and where I have the C. This will be a little bit easier to do in the actual problem because we'll have numbers instead of all these variables. But that's how the formula works. So it's the outside times the whole thing. And in the case of the first part, the outside and the whole thing are exactly the same because it's just a tangent. When you do the secant, like this guy here, the outside piece is 6. The whole thing is 6 plus 12. So the whole thing will be 18. So I'm going to just kind of use this formula as a guide here. So x times x would be x squared, has to be equal to, the outside piece here is the 6. And then the whole thing would be 6 plus 12 if I was looking at the formula here. So this will be x squared. This is going to end up being 6 times 18. This is 108 if you multiply those guys together. The only thing you have to do is just take the square root, and it'll say round to the nearest 10. So I'm just doing square root of 108 here. So like 10.4 is my answer. But you'll have that picture will be in the question, so you can reference that formula. All right, this next question is really good because it's going to review a couple concepts in the same question. Sorry, the diagram is so tiny. You have two angles going on here. So the angle I want to find is the one I'm highlighting right now, which is the angle with the vertex on the center of the circle. That's called a central angle. The other angle, which they're going to give me information about, is angle R. And if you notice, both of those angles intercept the circle in the points N and Q. But there's a different relationship between these two angles and the arc. So the arc they both run into goes from N to Q. It tells you that R is 23. Sorry, it's so tiny. Now, angle R, the vertex is on the circle, whereas angle O, the vertex is on the center of the circle. They do intercept the same arc. If I know angle R is 23, can anybody tell me what the arc from N to Q would measure? 46. Okay, it's double. If you are an angle whose vertex is on the circle, you can take the angle and double it to get the arc. Okay, now what's the relationship between that arc and the central angle? So if I know that arc, because that angle, that central angle, we're trying to find that intercepts that same arc. What's the relationship between the angle and the arc there? So what would you tell me the measure of angle O is? It's not if it's 23 if the vertex is on the circle. This angle, the vertex is on the center. It's 46. They're the same. If you have a central angle, which that's what O is, the central angle is equal to the arc. An inscribed angle, which is what R is the arc divided by 2. The difference is central angle, the vertex is on the center. Inscribed angle, the vertex is on the circle. Not on the center of the circle, on the circle. So that's kind of 2 questions in one. All right, let's look at 32. Now, on the actual test, you guys have a question like this, but the information will be in the diagram for you already. This one, it gives you a diagram and gives you information, so I'm just going to draw this on the picture here. So it says ON is 7x plus 2y. It says LM is 13. I'm just labeling this. NM is negative 2y plus x. And OL is 11. So we're just going through and just labeling. The actual question on the exam will have that labeled for you already, so you won't have to take the time to do that. Now, what we need to remember is that when we have a parallelogram, the opposite sides are congruent to each other, yes? So this is a little bit tricky to set up, but I would have, here, I'm going to come underneath here. So I'd have the 7x plus 2y equals 13, top and bottom are congruent, and you'd have the negative 2y plus x equals 11. The left side and the right side are congruent to each other. So this is a little bit weird because you have both variables involved in both equations. Probably the easiest way I could tell you to do this, I'm just going to do one step in this second equation. I'm going to add 2y to the other side there. My goal at this moment is just to get the x by itself because it would be easy to get a variable alone there. So I would just say that x is equal to 11 plus 2y. We have 2 equations with 2 different variables in each one. This is a system. So the easiest thing I can tell you to do, get that x alone real quick. And then what we can do is we can take this and substitute that in for x in the other equation. If we do that, that creates an equation that only has one variable, and then we can actually solve for it. So I'm going to come write it over here. So instead of 7x, I'm going to write 7 times 11 plus 2y plus another 2y equals 13. And do a little distributive property here. You get 77 plus 14y plus 2y equals 13. So I have 16y plus 77 is equal to 13. I know you guys could solve this real quickly. So we're just going to subtract 77. You get 16y. This is negative 64. And I'm going to divide by 16. So y is negative 4 there. And that throws people off because we're talking about a distance. That doesn't necessarily make one of the sides in that parallelogram negative. It's okay to get a negative value of a variable. It's not saying one of the sides is negative because I don't have like just y on one of the sides. Once you have y, all you have to do to get x is just plug it in like right here. So just 11 plus 2 times negative 4. So if I do 11 plus 2 times negative 4, I'm just substituting y in there. That means my x is going to be 3. So, oh, sorry, we don't have a lot of space. X is 3. And it would be very, very, very easy to check that. So the top right, we have 7x, so 7 times 3 plus 2 times y, which is negative 4. And I know that's supposed to be 13, which it is if you check that. The other side is negative 2 times y, so negative 2 times negative 4 plus x, which is 3, and that's supposed to be equal to 11, which it is. So that y being negative doesn't make a problem for that question. So those would be your two answers. X would be 3, and y would be negative 4. And then we're going to finish up with this last question today, and we'll pick up and do some more tomorrow. All right, the key to this question is that we have a circle and we have a line that says appears to be tangent. Go ahead and assume that it's tangent. We're going to find the measure of the angle where you guys see the x. And sorry, this is again kind of a tiny picture. This is 15 degrees. So, does anybody remember this would be a tangent line from P to Q. It's just going to touch the circle in Q. Does anybody remember if you have a tangent line and it connects to a radius, which is what it's doing here, what is the angle where Q's at? 90. That is the key to doing this question. That's a 90-degree angle. So you know inside angles of a triangle add up to 180. You're just going to do 180 minus the key to that being the 90-degree angle from the tangent line. So you're just going to take and subtract both of those from 180. The leftover has to be x. So this is going to be 75. Is anybody have any question? Okay. I know I just talked for a long time.